All right, welcome to the lunchtime video. Last video was a pretty big video. We learned a lot of good stuff. We learned about ISIS level 1, level 2 leaking. We submitted a correction to the official Juniper modification for where to apply that policy. We learned about how it prevents loops, because if it by default sends a route from a level 1 area to a level 2 area, well, that could be a problem if you leak it from a level 2 to a level 1 area, because it's going to get sent right back and you're going to have a loop, right? Wrong, because there's a special mechanism in ISIS where it has a flag associated with each route up or down, and if you leak it, it will change that flag to down, and then from area 1, it only leaks. But that default leaking behavior from area 1 to area 2 only happens if it has an up flag. So other routes that might have a down flag in addition to leaked routes are external routes. Anything that was redistributed from another protocol into ISIS will not be leaked from level 1 to level 2 by default. By default, it only applies to internal routes and only goes from level 1 to level 2 in that direction. Everything else needs a policy, which I am sure will be on the test. But I feel, for the most part, like I can figure that out. So I'm going to share my screen. I have had in previous videos trouble sharing the right screen. I'm not sure why. I think maybe I clicked. So yeah, I don't think I clicked properly the screen I intended to share. I just hit share screen and then I hit share again without clicking screen 2. So some of these videos are kind of not super useful, but if you need anything, well, I did have a commenter before saying that they want me to look at NG-MVPN and EVPN. So I will be looking at that when I'm done with this, and hopefully sharing the screen right. And I think I did watch today one of my earlier videos, and yeah, the sound is still a problem. It's just really muddy, you know, and I think just my natural speaking style isn't super clear anyway, but definitely doesn't help with the mic I'm using, but it's the best I can do without spending a lot, and I'm already spending a lot just to take this test, so. All right. And it's not like I have a dedicated large-scale audience or anything like that, but. Okay, so. Okay, so this is going to be the 7th video in the series on configuring and troubleshooting IGPs, specifically route policy, which is the last topic in this series. So a way I had approached this is to use the help apropos, as is the way I approach every topic now. But in that, I found all of these examples, so I wanted to go through those one by one. So the next one looks like it might be, I'm not sure what a next hop LSP is. It could be either for ISIS or for MPLS. But it looks like they do have the example up. Sometimes it's different. Yeah, so it has to do with MPLS. Let's skip this one for now because MPLS is going to be its own topic that I hopefully can get to soon. Time is really slipping away on me. All right, so let's see this destination prefixes one. Okay, it looks like all I've got is this grouping source and destination. Okay, so this belongs to routing policies, firewall filters, and traffic policers user guide, which is good because this is for learning about routing policy. So yeah, I think source class usage, I'm not sure if that'll be a part of it. Destination class usage, yeah, I'm not sure if this is going to be necessary or not. Let's see, because I don't have, I mean, it's just a general routing policy, and this is, of course, is a routing policy. We can see, I guess it's more accounting, but you can see we've got this policy statement, so it is a routing policy, but it's source class. So I guess I'm interested. Let me try doing a Google search for this and including the terms JNCIE-SP. So it'd be nice if I could do a must include. So here's looks like a workbook example. I'm not sure what this site is, but all I want to know is, more specifically, is this going to be on the JNCIE-SP? And this might be getting into an issue where, of course, you can't publish exact questions from the test. You know, that is in violation of their terms of agreement. So I don't think I will find that, no matter how hard I look, at least not from anyone following those terms of agreement. But I'm just not sure what I really need to study. And if this is on the exam, it might end up tanking me. But of course, I'm going to be tanked if I spend too much time on things that are not relevant. So one thing I can do, though, is I can say definitively, hey, you know, this is about IGP. It's about configuration and troubleshooting. So this is not about IGPs. This is source class. Let's see what source class is. So it counts packets sent to the customer edge. So that has nothing to do with IGPs. This is one I'm going to cross out and not work on. Oops, and these two, I think both of them, because I think they're the same thing. It's just they have instructions for doing it one direction, for the other direction, and then for both directions. But they're all source class usage configurations, which are not IGP configurations. So I don't think it's necessary for me to do those. Yeah, and this too is probably, yeah, this as well is not about IGPs. Looks like it's about BGP. So none of this is about that. So let's cross it all out. Okay, so yeah, I guess this is kind of a strange video because it appears that I'm really just done with this topic. So I'm actually going to go ahead and take the liberty of marking it done. Yep, so it's now done. So I can mark this whole thing done, which is good because I just wonder how much time I'm spending on this. It'd be great if I could get like a modification history and just see when I modified these files. But I'm completely done with IGP now, so it'd be wonderful if I could see when I first modified this and when I last modified this. I guess I can see that the last time I modified this, and the last modification I would have made was to close it out, was June 4th. So now it's June 26th. So that's going to be 22 days that I spent on this, because I last modified this on June 4th, which I can assume was the modification I just made now, setting it to done. And here is going to be my last modification, and I made it June 26th. So I spent 22 days on this module. Let's see if I have enough time to finish the other modules. So I have 22 days. I'm going to spend about 22 days on each module. I don't know if that's exactly right, but it's close enough. And then I've got 1, 2, 3, 4, 5 modules to go. Okay, so let's see how many days I'm going to need. So we've got 110 days I'm going to need to get through all of the modules, assuming that I've got 22, that I'm going to spend 22 days on each module. Let's see how many days there are from now until September 18th. $84 days. So yep, just as I thought, I'm moving at a snail's pace. Kind of a big problem. So I mean, I've been skipping the weekend videos. So like, well, shoot. Okay, but the good news is I finished this one and I'm ready to go on. I think I'm gonna jump right to. So I got a request from a subscriber to look at NVPN. I'm not sure exactly what that means to the person who requested, but I'm pretty sure that is Multicast VPN. In my reply, I said that it was, oh, yeah, I think I said it. I mentioned Multicast. I don't remember what I said in my reply, but I'll move on to that next, just to give a helper to somebody who subscribed. So this is notes. Okay, so then we'll just make one of these again. Okay, and I'll go a little bit out of order because they requested that. So then after I'm done with that, I'll go to the to EVPNs, layer 2. And then I'll just try to get back on the bandwagon. So it'll kind of throw off my stats a little bit. I won't be able to use the last modified to see how far I'm going. But I think I really, any time I spend doing that is kind of wasted, because I know essentially that I'm just spending far too much time. I'm really not going fast enough. So let's, okay, so let's change this, change up the tags. Okay, so now we're going to be talking about VPNs, layer 3 VPNs. Oh, sorry, not VPNs. We're not talking about VPNs. We're talking about multicast, NG-MVPN. So say MVPN, NG-MVPN. Okay. Okay, so I think these are good tags. So yeah, this is going to be the first video in that. We're not going to have a video 7 in that series. This is going to be the first video in this series. So let's fix the tags here. It's going to be multicast. And then it's going to be configuration and troubleshooting, just like the other one. But we're going to skip around, and we're going to do the first video on NG-MVPN. Okay, so we've got the notes for it here. So let's start it off the classic way. I start off any topic. Okay, so how I start any topic is I just pull up the CLI, log in, and then I do a help apropos using so for my search term, this is going to be MVPN, and then pipe match, and then the regular expression, it begins with an H, ELP. So yep, I've got all sorts of stuff. I've got a whole topic here for MVPN, so let's take a look at that. Oops, but it looks like I've got it. Okay, I think this is what I need. There we go. So configuring routing instances in multicast VPNs. To configure multicast VPNs, configure the MVPN statement. So it looks like it's pretty similar to a regular VPN. You've got the route targets. Oh, actually it does look like it might be a bit different. You can include this statement at the following hierarchy levels. By default, a multicast VPN routing instance is associated with both the multicast sender and the receiver sites. If you configure the receiver site option, the routing instance is associated with only multicast receiver sites. Configuring the sender site option associates the routing instance with only multicast sender sites. When you configure the routing instance for the multicast VPN, you must configure MPLS LSPs, either RSVP signaled or LDP signaled, between the PE routers of the routing instance to ensure MVPN multicast connectivity. P2NP LSPs are used for multicast data forwarding only. Okay, so that left a lot to be desired. Let's see if there's another thing that I can use. So let's look at this one. Configuring NLRI, network layer reachability information, parameters for multicast VPNs, virtual private networks. To configure IPv4 multicast VPN NLRI parameters, include the inet-MVPN statement. To configure IPv6 multicast VPN NLRI parameters, include the inet6-MVPN statement. You can include these statements at the following hierarchies. Okay, so that wasn't very helpful either. Yep, so this is the same documentation. It looks like it pulls up the same documentation for different topics. All right, let's take a look at this. Oh man. Well, it's going to be on the test. All right, so it's just a lot of reading. Well, let's see here. Yeah, it's got a It's got a whole section. Okay, well, so looks like I can narrow it down though, because the only thing on this exam is NG-MVPN. But if you want to find what I'm looking at here, here's the link. It's the Multicast Protocols User Guide. And then if you're looking to learn about draft Rosen or PIM joint and load balancing, there you go. I'm going to be focusing on this one. All right, so let's just read the understanding. Add it to the notes. Understanding next generation MVPN network topology. Layer 3 BGP-MPLS virtual private networks, VPNs, are widely deployed in today's networks worldwide. Multicast applications such as IPTV are rapidly gaining popularity, as is the number of networks with multiple media-rich services merging over a shared multi-protocol label switching MPLS infrastructure. The demand for delivering multicast service across a BGP-MPLS infrastructure in a scalable and reliable way is also increasing. RFC 4364 describes protocols and procedures for building unicast BGP-MPLS VPNs. Oops, and we got a car alarm going off, so I'll put this on. However, there is no framework specified in the RFC for provisioning multicast VPN and VPN services. Okay, so yeah, this isn't a good one to put in the notes because it includes everything but what we want to learn about, which is multicast VPN services. In the past, multi-protocol label switching virtual private network MVPN traffic was overlaid on top of a BGP-MPLS network using a virtual LAN model based on draft Rosen. Using the draft Rosen approach, service providers were faced with control and data plane scaling issues of an overlay model and the maintenance of two routing/forwarding mechanisms, one for VPN unicast service and one for VPN multicast service. For more information about the limitations of draft Rosen, see MBone. As a result, the IETF Layer 3 VPN Working Group published an Internet Draft IETF L3VPN 2547BIS ncast/10.txt multicast in MPLS/BGP IP VPNs. Okay, so here's the big ticket. This is the definitive first source for this technology. So I will be adding this one to the notes. Perfect. That outlines a different architecture for next generation MVPNs, as well as an accompanying RFC 2547 that proposes a BGP control plane for MVPNs. In turn, Juniper Networks delivered the industry's first implementation of BGP next generation MVPNs in 2007. Okay, this is another one, important one to have in the notes. There we go. Oh, is there anything for multicast? Okay, well, this is just explaining, this RFC is just for a BGP control plane, which can be used for MVPNs. It's not about MVPNs specifically. So I don't think this really belongs in the notes. Because there's nothing about multicast. Let's see what it says about that control plane. So it's a control plane. Okay, yeah, I don't think this is important to have in the notes. So just close that one. In turn, Juniper Networks delivered the industry's first implementation of BGP next generation NVPNs in 2007. Yeah, Juniper is definitely one of the oldest, biggest networking companies. So it's a big reason why I decided to go for this exam. All examples in this document refer to the network topology shown in Figure 1. The service provider in this example offers VPN unicast and multicast services to customer A, VPN A. The VPN multicast source is connected to site 1 and transmits data to groups 232.1.1.1 and 224.1.1.1. The VPN multicast source is connected to site 1 and transmits data to groups 232.1.1.1 and I already read that. Yeah, this is so dry and boring and dull. I can read two things twice without even realizing that I read it. VPN multicast receivers are connected to Site 2 and Site 3. The provider edge router 1, router PE1 VRF table acts as the C-RP using address 10.12.53.1 for C-PIM-SM ASM groups. The service provider uses RSVP-TE point-to-multipoint LSPs for transmitting VPN multicast data across the network. All right, so that's it. Let's see what's next. Understanding next generation NVPN concepts and terminology. This section includes background material about how next generation VPNs work, route distinguisher and VRF route target extended community. Route distinguisher and VPN routing and forwarding VRF route target extended communities are an integral part of unicast BGP-MPLS virtual private networks, VPNs. Route distinguisher and route target are often confused in terms of their purpose in BGP-MPLS networks, as they play an important role in BGP next generation NVPNs. It is important to understand what they are and how they are used as described in RFC 4364. So before I go any further, I totally agree with that. Route distinguishers and route targets are completely confused. I, for the longest time, was absolutely confused. I did not understand the difference. I did not understand which need to match, which were okay not to match. But now, because I did the video for 960, I already did, well, I didn't do videos. I think I started like halfway through the VPN section, but I did finish studying for VPNs. It was a while ago, a long time ago, but I think based on my studying, and then this is kind of the main thing, one of the main things I have hands-on experience in is checking route distinguishers and checking route targets and looking at this kind of configuration out in the wild. That's a lot of what I did. So I do have some sense of what the difference is between those two. But of course, we all hopefully it's not always the case in every environment. But there are environments. I'm not necessarily speaking. Well, let me just say that even if you have day-to-day experience going in, looking at route distinguishers, route targets and stuff, that's not necessarily a guarantee that you know all the technology behind it. There's, of course, I mean, we could see like the, yeah, so long story short, I haven't read this. Of course, this is for MVPNs, not route distinguishers or route targets, but those have these, and I have not read those. And in order to do the job properly, in most jobs, it's just not necessary. It's necessary to do a kind of a more planning, generation, making kind of higher level decisions. But if you're on the computer at the keyboard making the configurations, it's not necessarily anything you need to do, and it would be absolutely absurdly ridiculous to expect CCIE, JNCIE level knowledge from somebody who you wanted to do that, because that knowledge is so rare and so hard to get. Really, there's no harm in letting somebody configure route distinguishers, configure route targets who don't know exactly what they do. But I believe that I do know what they do. So let's write out my own definitions for them before moving on, and we'll see how close I come. So route distinguisher. So let's write out the format for this, which it's going to be rough. It's going to be rough. It's going to be rough. I mean, and the thing is, on the test, I'll have the devices, so I can use the help menu. I can go into the hierarchy. I can question mark. So why don't I just use that, because I'm going to have it during the test. So I'll be in the situation, and instead of doing what I did and go why don't I just use the tools that are available to me? So that's my rule for this. I'm still going to do the same exercise, but I'm going to use tools for it because I will have these tools during the test. Okay, so let's do a help apropos distinguisher. Here we go. So I get basically something like this during the test. So there's really no harm, no shame in reading this, because it's not something that will leave me hanging later on. Let me space it out more so it's more obvious to see where it starts. Configuring the route distinguisher. Each routing instance that you configure on a PE must have a unique route distinguisher associated with it. VPN routing instances need a route distinguisher to help the BGP to distinguish between potentially identical network layer reachability information messages received from different VPNs. We recommend that you use a unique route distinguisher for each routing instance that you configure, although you can use the same route distinguisher on all PE routers in the same VPN. If you use a unique route distinguisher, you can determine the PE router from which a route originated. To configure a route distinguisher on a PE router, include the route distinguisher statements. So let's start off with my own definition, and it didn't come straight out of my head. It came from me using a reference tool, but it came from me using a reference tool I'll have available to me when I take the exam. So no harm, no foul. So let's define the format first. So the formats can be either AS, autonomous system number, and then a custom number, or an IP address, and then as well a custom number. So it can come in two formats. The other important thing to know about route distinguishers is that it is recommended to use a unique one for each routing instance. So on a device, you're going to have when you look at your configuration, you're going to have some configuration. Let's say that you have routing instances. You're going to have one routing instance, two routing instances. So if you have multiple routing instances, in that case, definitely it's a good idea to use a different. Yeah, so you've got to use different routing distinguishers in this case. I think you can use all the same, but I actually don't know. It's been a bit too long for me to really say this definitively. But let's just make the note here saying that it is recommended to use a unique route distinguisher for each routing instance. It is recommended to use a unique routing distinguisher for each routing instance, meaning that each instance on each PE gets a unique RD. Okay, so if we have, let me pull up Paint. So let's say we have 3 PEs. So, and then let's say on this one, we've got 2 routing instances. And then these two, just for simplicity, we only have 1. So our routing distinguisher, and we know the format for it is going to be an ASN and then a custom number separated by a colon. And then, of course, another format you can have is a IP address with a colon and then any number you want. I don't know what the limit is for the length of the number. But as you can see, I'm doing here, the proper way to have a route distinguisher is to make sure that all of these distinguishers are unique as they are here. That's the proper way to do it. So across devices and then across instances on the same device, it's always unique. They recommend never having a duplicate route distinguisher in any topology. Okay, so it looks like there's just some more reading to do here. You can configure the route distinguisher statement at the following levels: edit routing instances, routing instance name, edit logical routers. So we tried to do that in a previous video, it didn't quite work, so skip that. The route distinguisher is a 6-byte value that you can specify in one of the following formats: AS-number, :number, where AS number is an autonomous system AS number, a 2-byte value, and number is any 4-byte value. The AS number can be in the range 1 through 65,535. We recommend that you use an Internet Assigned Numbers Authority, IANA assigned non-private AS number, preferably the Internet Service Provider's ISP's own or the customer's own AS number. IP dash address colon number, where IP address is an IP address, a 4-byte value, and number is any 2-byte value. The IP address can be any globally unique unicast address. We recommend that you use the address that you configure in the router ID statement, which is a non-private address in your assigned prefix range. So one thing I might have made unclear in my example here, where we've got 3 routers and then we've got routing instances in each of them. So you can have a unique routing distinguisher even if the first part matches. So if they're all 1, 2, 3 colon, but we've got 1, 2, 3 colon 2, and then 1, 2, 3 colon, or 1, 2, 3, 4 colon 3, there's still unique routing distinguishers, even though either the first part or the second part matches. As long as any character is different, they are totally unique. I think. I mean, it might not be that case, but we can do an experiment to see if that's the case. But as far as I know, that is how it is. Okay, so let's continue reading the. Oh, actually, before we do that, so I'm done with my own definition using the tools I will have available to me on the exam. So let's do the same thing for a route target before we read the rest of the documentation that will hopefully give us a more clear answer, at least in the context of NVPNs. Okay, so let's do same thing here, but let's do targets. Here we go. So we've got a BGP route target. We've got NVPN targets. I think this is it. So hopefully we got some good documentation for that. Okay, let's space it out so it's easier. There we go. Configuring BGP route target filtering for VPNs. BGP route target filtering is enabled through the exchange of the route target address family stored in the bgp.rtargets.0 routing table. Based on the route-target address family, the route target NLRI address family indicator AFI equals 1, subsequent AFI equals 132 is negotiated with its peers. On a system that has locally configured VRF instances, BGP automatically generates local routes corresponding to targets referenced in the VRF import policies. To configure BGP route target filtering, include the family route target statement. So I don't think this is good. I think this is just about route target filtering. It's not talking about route targets themselves. So I'm gonna move on. Yeah, let's see what this one says. Oh, this is about filtering as well. And then that's for BGP, which I don't think is good to look at for VPNs. Let's look at this one since we are learning about NVPNs. Here we go. Configure VRF route targets for routing instances in multicast VPNs. By default, the VPN routing and forwarding VRF import and export route targets configured either using VRF import and export policies or using the VRF-target statement are used for importing and exporting routes with the multicast VPN network layer reachability information. You can use the export-target and import-target statements to override the default VRF import and export route targets. Export and import targets can also be specified specifically for sender sites or receiver sites, or can be borrowed from a configured unicast route target. Note that a sender site export route to target is always advertised when security association routes are exported. Note, when you configure a multicast VPN routing instance, you should not configure a route target value for a multicast VPN specific route target that is identical to a route target value for a unicast route target configured in another routing instance. Specifying route targets in the multicast VPN NLRI for sender and receiver sites is useful when there is a mix of sender only, receiver only, and sender and receiver sites. A sender site route target is used for exporting automatic discovery routes by a sender site and for importing automatic discovery routes by a receiver site. A receiver site route target is used for exporting routes by a receiver site and importing routes by a sender site. A sender and receiver site exports and imports routes with both route targets. A provider edge PE router with sites in a specific multicast VPN must determine whether a received automatic discovery route is from a sender site or receiver site based on the following. If the PE router is configured to be only in a sender site, route targets are imported only from receiver sites. Imported automatic discovery routes must be from a receiver site. If the PE router is configured to be only in a receiver site, route targets are imported only from sender sites. Imported automatic discovery routes must be from a sender site. If a PE router is configured to be in both sender sites and receiver sites, these guidelines apply. Along with an import route target, you can optionally configure whether the route target is from a receiver or a sender site. If a configuration is not provided, an imported automatic discovery route is treated as belonging to both the sender site set and the receiver site set. To configure a route target for the multicast VPN routing instance, include the route target statement. You can include this statement at the following hierarchy levels. The following sections describes how to configure the export target and the import target for a multicast VPN. And I can't search these. These are pretty much pulled right from the documentation on the website. So they expect you to be able to navigate these as you would a web browser. But that is not possible from the CLI. Unfortunately, that would be really useful. And I tried to write out a script where I could do that. Might want to devote another video to trying that because it'd be such a game changer on the exam if I could just say, boom, you know, this, and then start shell. Like that, and then do Python search help.py, and then just yeah, and then just do like that. Like, yeah, if I could do something like that, and then it'll show me, it'll give me back the let's see here. So if I do yeah, and it'll spit out like this for me, and then I can go back here and print that out and see. Oh man, that would be a huge game changer. I'm sure it'll only be a few lines of code. I devoted a video in the past to trying to figure that out, and it just turned out to really not work in the way I kind of thought it would. And I believe I came to the conclusion that it's just not possible. But it's rare that, I mean, they're Turing complete machines. Anything's possible. So, well, unless it's not Turing complete, then not anything's possible. So perhaps it's not Turing complete. All right. So, yep, I read this already. So let's keep looking. Okay, let's look at this. So these are routing instances. So that's for layer 3 VPNs. So yeah, this looks like what I'm looking for, because this NG-MVPN, I believe, is going to apply to a layer 3 VPN. We'll find out in a minute, because we'll keep reading that documentation. But let's just read this first, try to come up with my own definition, and then keep reading that documentation. Configuring a VRF target. Configuring a VPN routing and forwarding VRF target provides a configurable community within a VRF routing instance and allows a single policy for import and a single policy for export to replace the per VRF policies for every community. To configure a route target, include the route target statement. Use the import and export options to specify the allowed communities to accept from neighbors and to send to neighbors. You can configure these statements at the following hierarchy levels. Within a hub and spoke configuration, you can configure a PE router not to advertise VPN routes from the primary hub instance. Instead, these routes are advertised from the secondary downstream instance. You can do this without configuring routing table groups by using the no-VRF advertise statement. Note, this statement does not prevent the exportation of VPN routes to other VRFs on the same router by configuring the edit routing options auto export statement. To prevent advertising VPN routes from the primary instance, include the no-VRF advertise statement. You can configure these statements at the following hierarchy levels. Okay, so see the Junos VPN's configuration guide. I'm kind of curious to see that. Okay, so let's write down my definition. Unfortunately, this documentation kind of, I feel like, left me stranded in the water. Yeah, so I don't know what a community name is. I don't know. Let's see if we can get. So we've got to add a community there. I don't know what a community is. Maybe I can find more information by searching for that. Maybe there's something under, yeah, VPNs, PE community. Yeah, is there something like here? I think I was just looking at that. Yeah, this looks better. So configuring a VRF target community using the VRF statement causes a default VRF import and export policies to be generated that can accept and tag routes with the specified target community. And I'm going to clean this up so it's easier. You can still create more complex policies by explicitly configuring VRF import and export policies. These policies override the default policies generated when you configure the VRF target statement. If you do not configure the import and export options of the VRF target statement, the specified community string is applied in both directions. The import and export keywords give you more flexibility, allowing you to specify a different community for each direction. The syntax for the VRF target community is not a name. You must specify it in the format target:x:"y". Okay, so this is what I thought. And this looks very familiar to me. Let's print this out more cleanly again. Okay, a community name cannot be specified because this would also require you to configure the community members for that community using the policy options statement. If you define the policy-option statements, then you can just configure VRF import and export policies as well. The purpose of the VRF/target statement is to simplify the configuration by allowing you to configure most statements at the edit routing instances hierarchy level. Okay, so let's do a similar definition here. So format, you've only got one kind of format for this time. It's going to be target and then XY, where X and Y are just numbers you can choose, from what I understand, at least from what I know from memory. Okay, and now let's do a plain text definition. So it's just used for filtering, used for route filtering and import export policies. A bust match across all routers. That's what I believe my definitions are. So unfortunately, I might need to, yeah, I think I'm going to need to end the video here. I don't have a meeting like I normally do on Tuesdays and Thursdays today, but I do need to do stuff. So I'm going to be saving this for later, and then in the, well, I do have 2 minutes. So if it's right there, yeah. So, well, no, I'm just not going to be able to have enough time. So we'll say next video, answer key. Okay, so that's the end of this video. I'll see you in the next one where I read over the answer key for these definitions and see how close I came to what I could figure out with my own knowledge and with the resources that will be available to me on the exam. So thanks for watching, and I'll see you in the next one.